This video is brought to you by mywayteaching.com.
In this part, we are going to study vector addition by analytical method. So we already studied the vector addition by graphical method. Now we are going to study vector addition by analytical method. Okay. Although the graphical method of adding vectors helps us in visualizing the vectors and the resultant vector, it is sometimes tedious and it has limited accuracy. So one of the disadvantages of this graphical method of adding vectors is that it is of less accurate. Okay, the accuracy is less compared to this analytical method, and it is much easier to add vectors by combining their respective components. So you just consider two vectors A and B in xy plane. Okay, you consider two vectors, vector A and vector B in xy plane with components. What are the components of A? Yes, with components AX, AY, BX and BY respectively. So we can represent vector A by using the components, that is AX I cap plus AY J cap. We already saw this one, isn't it? So let us consider this as equation 1, and we can also represent vector B using the components Bx as well as By, that is Bx into I cap plus By into J cap. So now we represented vectors A and B using the components Ax, Ay, Bx, By respectively. So let us take R as the resultant vector that we get after adding the vectors A and B. So R can be written as A plus B, isn't it? R be their sum. So we know the value of Ax, that is Ax is represented using Ax into I cap plus Ay into J cap plus the vector B can be represented as Bx into I cap plus By into J cap, isn't it? Since vectors obey the commutative and associative laws, we can arrange and regroup the vectors of this equation 2. So we already know vectors obey commutative as well as associative property, isn't it? So by rearranging this vector, we can take I cap one side, Ax plus Bx into I cap plus Ay plus By into J cap. Okay, this is the vector R. And we also know the vector R, that is the resultant vector, can be represented using components, that is Rx I cap plus Ry j cap, isn't it? We can represent vector r using the components rx and ry. So let us take it as equation number 3. Okay. And if you compare equation number 2, that is what we got after simplifying this equation. If you compare equation 2 with equation 3, in place of rx, we have ax plus bx, isn't it? And in place of ry, we have ay plus by. You can see this. So we can write rx is equal to ax plus bx and ry is equal to what? Yes, it is equal to ay plus by. Thus, each component of the resultant vector R is the sum of the corresponding components of A and B, isn't it? Each component of the resultant vector R is the sum of the corresponding components of A and B. So, we can see that Rx is equal to Ax plus Bx and Ry is equal to Ay plus By. And if this is a case of two dimension, if you are considering in three dimensions, okay, if you are considering the case of three dimension, then how can you represent A? Yes, A can be represented by ax into I cap plus ay into j cap plus az into k cap, isn't it? This is the vector A. And similarly, we can represent vector B also. Vector B can be represented as bx into I cap, by into j cap, and bz into k cap. Okay. And the resultant vector R can be represented as R is equal to A plus B. So, the resultant vector can be represented as Rx into I cap plus Ry into j cap, yes, Rz into k cap. So, we are representing the resultant vector by using its components Rx, Ry, Rz. So, we also represent, okay, here we can see A is also represented using the components Ax, Ay and Az, and B is also represented using its components Bx, By and Bz. So, by comparing resultant vector A plus B, that is the components A and B, as we did in the previous case, that is in two dimension, we get Rx is equal to Ax plus Bx, isn't it? And Ry is equal to Ay plus By and Rz is equal to Az plus Bz. Okay, let us consider this as equation number 4. So this method can be extended to addition and subtraction of any number of vectors. For example, if vectors A, B, C are given as, so if this method we can extend it for n number of vectors to perform addition, subtraction. So if just consider we are given with the vectors A, B and C, and the vector A is given by ax into I cap plus ay into j cap plus az into k cap. Okay, and the vector b can be represented as bx into I cap by into j cap and bz into k cap. Okay, it is an example where we are given with three vectors a, b and c, and vector c can be represented cx into I cap cy into j cap cz into k cap. Okay, these are the given vectors. Then if we want to find a vector t, and that is given by a plus b minus c, then this vector t we can get it by doing addition of vectors a and b, and with the result what we get after adding vectors a and b, we'll subtract it with the vector c, isn't it? So if you perform this, we get the components tx, ty, tz again. So that tx component is given by ax plus bx minus cx, isn't it? And the component ty is given by ay, by minus cy. And the vector component tz is given by az plus bz minus cz. So we can consider this as equation number 5. Okay, here that we are given with the vectors a, b, c, and those vectors are represented using its components. That is, a is represented using ax into I cap plus ay into j cap plus az into k cap, and the vector b is represented using its components, and that is given with bx into I cap plus by into j cap plus bz into k cap, and the vector c is given with cx into I cap plus cy into j cap plus cz into k cap. Okay, and if the resultant vector is t, and that resultant vector we get after adding the vectors a and b and then subtracting the vector c from the result, isn't it? So if you perform this particular addition and subtraction, we get three components of vector t, that is tx, ty and tz, and tz is given by ax plus bx minus cx, and ty is given with ay plus by minus cy, and similarly the component tz is given with az plus bz minus cz. So this is a method of vector addition, that is by using analytical method, where we are just add the components in order to get the the resultant vector after addition. Or if you want to get the the resultant vector after subtracting two vectors, we can also get the result by subtracting the components of two vectors. Okay, no need of doing much things. It is very simple. If you just subtract the components, we'll get the resultant vector after subtraction. And if you want to get the sum of two vectors, you can just add the components of two vectors. You will get the resultant vector after addition. So this is a very simple method.